about TLC, HPTLC, you remember they are known as planar chromatography. Okay, so welcome you for one more video over here for TLC and HPTLC. Now, what is thin layer chromatography and high performance thin layer chromatography mean? First of all, it is a planar chromatography. It is very important to understand the planar chromatography. The meaning is that the stationary phase is applied on a plane surface. That means you have a plane surface where you apply your stationary phase. Okay. Now the stationary phase can be made up of either it can be made up of paper, that is with help of alpha cellulose paper, okay, or it can be made up of silica gel. Please refer to our earlier video in chromatography and HPLC in our YouTube channel, what I have already mentioned. Okay, then you can come back to this video, TLC and HPTLC. Now the thing is, in paper chromatography we follow different type of development. Like for example, if I talk about first point about principle of planar chromatography. So in this technique, mobile phase is drawn up the plate or drawn up to the planar surface via capillary action. So that means somewhere over here, if we are applying our sample, then the mobile phase, like, we'll be keeping them to a chamber, okay, developing chamber, okay, and this is your mobile phase. Now the moment you are keeping the plate in the chamber, the mobile phase is going to be drawn up with the help of capillary action. Okay. Now different analytes, okay, if you know, I have already explained, different analytes ascend, that is different analyte ascend, okay, the TLC plate at a different rate, okay. So this is the principle, and the separation process can be explained by either the plate theory which explain the separation via RF, that is retardation factor, already I have discussed in my chromatography video, or by the rate theory, that is capacity factor. Okay. Now in TLC and HPTLC we use the plate theory, okay, that is retention factor. So normally if the mobile phase developed up to this and the spot may be separated, this is pure spot and this is like mixture of A and B. So this is developed in the TLC. So after principle you have second thing, that instrumentation, okay, or working, instrumentation and working. So first thing is mobile phase. Mobile phase, you have elution strength as per elution. I think already mentioned heliotropic series, okay, elution strength of mobile phase. You have hexane, then carbon tetrachloride, benzene, toluene, dichloromethane, diethyl ether, ethyl acetate, acetonitrile, acetone, N-butanol, water, methanol, acetic acid and formic acid. This is the elution strength of mobile phase. Okay, we use this particular series, and normally HPTLC and TLC we prefer normal phase chromatography. That means the stationary phase is polar. Okay, so non-polar mobile phase we take over here, specifically hexane, carbon tetrachloride, benzene, toluene, to the till your butanol. Okay, water, methanol, acetic acid we use, but very rare. Okay, their strength, their maybe ratio will be very rare in that. Okay, Now we use ammonia can be used as a buffer. The sample can be put up to 1 to 10 microliter, okay, sample, and there are different types of technique to separate. That is, one we use two-dimensional chromatography, 2D chromatography. So what is 2D chromatography? Once we develop this plate like this, we rotate them again to the 90-degree angle. Means I use white. I rotate the chromatographic plate with a 90 degree. Now this was my first development, and like this, okay, and now the second development is exactly we use, okay, over here. So now the development takes place like this. So this 2D chromatography, what help us, the 2D TLC. Now thin layer chromatography is nothing but when we are applying a thin layer of stationary phase on this planar surface. Okay, so two-dimensional TLC involves using two solvents or two type of solvent system and rotating plate at 90 degree, because if you see we are rotating the plate at 90 degree, okay, in between. This is useful to separate complex mixtures such as amino acids, okay. So this is a different type. Now coming to the preparation of plate. So how we can prepare the plate in chromatographic technique. So let me discuss with this concept. First we activate silica gel in hot air oven, okay. Silica gel for 30 minutes at 110 degree temperature. This is the activation of silica gel, okay, silica gel powder. And then we can use gypsum as a binder, and the particle size of silica gel is 5 to 20 micrometer normally, okay. Now when we are applying the TLC layer, there should be a thickness also, okay. So thickness, for normal, for analytical purpose, the thickness is 0.1 to 0.25 mm. 0.1 to 0.25 mm for analytical purpose. But if we use preparative purpose, that means for isolation purpose, okay, that time we use the thickness around 0.5 to 2 mm. 0.5 to 2, yes, it is more, 2 mm, okay. So this is the difference, because we are going for isolation the things. Now after that, the development, so the thing is now the surface, the planar surface in TLC is quite small. So that's why if we want to load more sample or in a band, in a